So, welcome to lecture 14, inheritance. In the last lecture, when we talked about inheritance, right, so the visibility where class B may privately inherit class A, or in a protected way it can inherit class A, or what will happen if class B is publicly inheriting class A. So, in that case, suppose the inheritance is public, all right. So, in the case of private, it will not be inherited. So, you can see the table where the private case, whether it is a public or private or protected, the access level in derived class, it will not be inherited. Whereas the protected case, right, the public will become protected, the private will become private, and protected case it will become protected. And in the case of public, in the public inheritance, right, the base class access level if it is public. So, in the public level, right, in the case of access level in derived class, the public inheritance it will become public, and private inheritance it will become private, and in the case of a protected it will become protected, right. So, these are all the cases. So, we can inherit. So, in fact, we had seen the case of what will happen if it is publicly inherited or if it is privately inherited, that we had seen, right. So, in the case of a protected, so assume that the base class access level if it is protected, and the access level in derived class in the public inheritance it will become protected, and the private inheritance it will become private, and the protected inheritance it will become protected, right. So, we have already seen simple inheritance and multi-level inheritance. And what do you mean by multiple inheritance? Suppose you have class A, class B and class C. Assume that class A is inheriting both class A and class B, right, as you are seeing in this particular figure, right. So, let us see what will happen. So, let us consider a example from C++, right. So, the multiple inheritance, so assume that using namespace std, right. So, because we are going to use cout, so we use using namespace std. Let us assume that you have class A, right. Assume that you have class A. So, you have one protected member data A and you have a public member function get A, right. So, you are passing the parameter, that parameter will be copied into A. So, that is your class A. Now, your class B is defined, you have one data member B, similarly get underscore B member function. So, n will be copied into B, alright. So, this is a member function in class B and you have one protected member data B. So, now this is the syntax that you are seeing when class C inheriting both A and C publicly, right, both A and C publicly, what the syntax that you are seeing, alright, and then you are defining public void display, you have cout, the value of A is A, alright. So, it can access A because, so you are inheriting public and you have protected member data. So, the protected member data will become, alright, it can access in fact by C, alright, A and B can access. So, the value of A, right, so that will be printed. So, protected publicly you are inheriting. So, A and B can be accessible, that is what in the first slide we had seen, and next cout is B and another one is A plus B, right. So, this is what class C is doing. Class C you have one member function called display. So, now in the main program let us create a class, let us create an object C whose class is capital C. Now, this object is invoking get underscore A by passing 10. So, get underscore A when you are passing 10, what is happening? Get underscore A when you are passing 10. So, A n is 10. So, that will be copied into A. So, A will become 10, right, and the same object C is invoking get underscore B by passing 20, right. So, now in that case what will happen, n it is 20. So, B will take the value 20. So, what is the A value 10 and B is taking the value 20, right. So, now the third function, it is invoking the third function C dot display, alright. So, when it is invoking display, A will be printed. So, we know what is A is 10, right, and B is 20, and what about A plus B? A plus B should be 10 plus 20, 30. So, this output we have to get. So, when you run the code, you have to get 10, 20 and the addition of 10 and 20, we know it is 30, right. So, you can see the output over here, right. So, you can see the output. So, the main idea over here is the line number 24. Class C, which is inheriting both A and B, that means it is using the property A and B publicly, right. So, in that case, since it is a protected member data and public, right. So, we know that, right. So, we know that. So, the base class you have a protected and here it is a public, protected will become again protected. So, the member data will be again protected, right. So, base class access level, right. So, you have the protected member data and when you do public inheritance, the data will become again protected. So, that means the data int A, right, will become protected in class C. Similarly, int B will be protected in class C, and line number 24, class C is inheriting A and B, right. So, this is the example of the multiple inheritance. So, there are cases. So, you have an ambiguity, right. So, suppose class A you have one display, assume that it is C out class A, and class B again you have display, right. So, class A you have display and class B is also having the display method, right, display function, member function, that is displaying class B. So, now class A is publicly inheriting both A and B, right. So, the now when class C is having a member function view and then it is calling display, then there will be a problem. So, which display function will be called? Will it call A or B, alright. So, that is why this particular program you will get an ambiguity. So, you have object C under capital C, class C, and this object is invoking, let us say, view, right. So, display will be called. So, which display, right, this will invoke? You have two display, line number 6 you have display and line number 14 also you have display. So, in that case, so which function will be called will be the ambiguity and you will get the error, right. So, the display is ambiguous, right. So, void B we have to write like this, that we will take care how we are going to make it, otherwise, so you can see the error, right. So, this is giving an error, the reason is the compiler is getting confused which display member function should be called, right. So, how do you take care this ambiguity? So, what we have to do, the same program, right, line number 19 onwards I am continuing, same program, right, first 18 lines are same and the 19th line onwards I am making this particular change, right. So, what we have to do, we have to explicitly call the display of class A. So, in that case what you have to do, put A followed by 2 colons. So, this is what exactly we are doing. If you look at, so we used to put std double colon C out, do you recall, alright. So, explicitly I am calling from std. So, that means inbuilt class, std is an inbuilt class, I am doing like this. So, C out, right. So, this is what we have written, in fact we have written in several cases, yes, here itself, look at line number 8, right. So, that means in order to solve this ambiguity, what we are getting in line number 23, right. So, which function has to be called, which member function has to be called. So, this will be solved when you are explicitly call the display of class A and explicitly call the display of class B. So, that you have to do A double colon, similarly B double colon. So, that means when you write A double colon display, your class A display will be called. So, first class A will be printed, next class B will be printed, alright. So, this is how when you run the code you have to get the output like this. So, class A, class B will be displayed. This is how we can resolve. Now, when Java point of view, with respect to class we do not have the concept of multiple inheritance, right. We do not have the concept of multiple inheritance in Java, right, with respect to class. So, for this we have to introduce the concept called interface in Java. So, the interface will take care this multiple inheritance problem, right. So, that we will see when the interfaces concept comes, okay. So, again we will recall this multiple inheritance concept, right, when we talk about Java. So, we will see how we are going to take care. So, the multiple inheritance concept you can't find it in Java. So, obviously, you do not have hybrid inheritance also in Java, whereas In C++, we have already seen, so it is there. So, in the case of hybrid inheritance, so let us see what will happen in the case of hybrid inheritance. So, assume that you have class A. So, the class A almost similar what we have written, right. You have protected member data called A, right, and void get underscore A. So, you are taking, right, so you are taking the input from the user C in A, right, you are printing enter the value of A, right, get underscore A is a member function, int A get underscore A, enter the value of A, right, you are taking the input from the user. So, that is of class A, and class B which is publicly inheriting class A. So, you have class A and class B which is publicly inheriting class A, right. So, you have protected member data and then get underscore B, you are taking the input from the user. So, that is class B, and you have class C, right. So, assume that you have class C. So, you have a protected member data called C, right, and then you have get C which is taking the input from the user C in C, right. So, you have C, I will just simply write C. B is publicly inheriting over here. So, which is having a variable C, right, member data C, small c, and then it is taking the input from the user. Now, class D which is publicly inheriting B and C, right, class D which is publicly inheriting class B and C, is publicly inheriting class B and C, right. You have protected member data D, and then assume that you have one member function called multiplication. So, the multiplication you have get underscore A, get underscore B and get underscore C, alright. So, you are calling these three functions, then you are doing multiplication of that three numbers. So, get underscore A, right. So, if you look at the diagram, so D can access B and B can access A, right. So, D can access B and B can access A. So, there is no problem. So, get underscore A, you are taking the input from the user, right. So, A you can take input from the user. So, this can be accessed, right, the hybrid inheritance, right. And class B which is having get underscore B, right, you are taking the input from the user. So, A, B you have taken the input from the user, right, and then class D can access C as well, right. So, class D can access C as well. So, class C you have get underscore C. So, you are taking the input from the user C in C. So, now what will happen, right, you have A, B, C from line number 45, 46 and 47. So, the multiplication of this A, B, C will give you, right, whatever number you are taking. For example, I am giving 10, 10, 10. So, the answer will be 10 into 10 into 10, right, 1000 will be the output if the input you are giving 10, 10, 10, right. So, now we will see how this will happen, right. So, the class is over, class D will be over here. Now, I am going to the main program, creating an object D, small d under capital D. Capital D is the class. So, now this small d invoke the multiplication function, multiplication member function. So, getting A, B, C, right, from the user and multiplication of A, B, C, right. So, assume that I am giving 10, 5 and 5, right. So, 10 into 5, 50, 50 into 5, 250 I have to get the output, right. So, let us see what is the input I am giving. Assume that I am giving the input 20, 30 and 40, right. So, the multiplication of these three, right, 2 into 3 into 4, 24 followed by 3 zeros. So, 24,000 will be my output, alright. So, A, B, C you are giving as an input and it is calling get underscore A, get underscore B and get underscore C. So, you are getting the output 24,000, right. So, this is how the hybrid inheritance is working, right. So, this is how the hybrid inheritance is working. So, similarly, like what we had seen in the case of multiple inheritance in Java, you obviously do not have hybrid inheritance, right. You obviously do not have the hybrid inheritance. So, in fact, in this particular problem, we have the hybrid inheritance like this, right. B is inheriting A and D is inheriting both B and C, right. But whereas, if the same problem we require to solve in Java, we cannot do that because Java does not support this multiple inheritance. So, here you have this multiple inheritance, D is, right, multiply inheriting B and C, right. So, this concept we cannot see. So, hybrid inheritance also not available in Java. So, in Java you can't find both multiple and obviously hybrid inheritance is not there. So, hybrid inheritance is nothing but the multiple and the multi-level or the single inheritance, right, the combination. So, when the multiple inheritance is not there, obviously you do not have this hybrid inheritance also in Java, alright. So, with this the next concept, hierarchical inheritance, right. What do you mean by hierarchical inheritance? So, suppose class B and class Z, right, class B is inheriting class A and class C is inheriting class A, alright. So, is it possible? Yes, in C++, also in Java it is possible. So, now we are going to see how this can happen. So, suppose I have, let us assume that class shape, right, assume that I have class shape. So, you have two member data A and B, right, you have two member data A and B and you have get underscore data member function. So, that means whatever you are passing n and m will be stored in A and B, alright. Whatever you are passing here, you are seeing the arguments n and m. So, that will be stored in A and B, right. So, now let us assume that I have a class rectangle, another class rectangle. So, here you have class shape. So, shape is the base class, right. So, here you go, I have shape where the class rectangle is inheriting shape, class rectangle is inheriting shape. So, here you have one member function, right. So, that member function you are finding out the area of the rectangle, right, rect underscore area. So, the result will be A star B. So, since it is inheriting shape, in the shape you have this A and B, whatever you are passing get data, right. So, that you are setting over here. So, A and B value can be accessed by rectangle. If you look at the figure, so they are publicly inheriting, right. So, A and B will be multiplied and that will be stored in the result, and line number 20 you can see it will be returned, right. So, that is your rectangle member function. So, now I have another member function called triangle, right. I have another member function called triangle, right. So, here, so let us see how it is going. So, you have a member function triangle which is again inheriting shape, alright. So, that is why it is called hierarchical. So, rectangle also is inheriting shape, triangle is also inheriting shape, which is possible in C++. Also we are going to see this is possible in Java as well, right. So, now your triangle which is inheriting shape, alright. So, triangle which is inheriting shape, alright. So, here you go. So, you have triangle area, right, your member function is called triangle area. So, the float result you have 0.5 into A into B, right, of BH, right. So, whatever you are passing the base and height, so of into A into B passing as the number get data number, right, the numbers. So, A and B, so A and B can be accessed by triangle as well because triangle is inheriting shape, right. So, of into A into B, so that will be stored in the result and then return result, right. So, these three classes. So, shape is the base class, rectangle is a derived class from shape, similarly triangle is also derived class from shape. So, if you do this scenario, so you call this as hierarchical inheritance, right, you call this scenario as hierarchical inheritance. So, now let us consider the main program. So, in the main program assume that you have an object R, right, assume that you have an object R, alright. So, whose class is rectangle and then you have another object called T, right, whose object is, right, whose class is triangle, object is T, whose class is triangle. So, here you have 4 variables length, breadth, base and height, alright. So, I am going to give us a data. So, the get data. So, enter the length and breadth of a rectangle, right, enter the length and the breadth of a rectangle. So, when you do this, you are taking the input length and breadth from the user, line number 38, right, and then the object R that you have created under rectangle, right. So, here you have object R, so that you have created under rectangle, correct. So, that will be invoking get data. You are passing length and breadth, correct. So, you are passing length and breadth. So, assume that I am passing, let us say 10 and 20, right, without loss of generality, 10 and 20, length is 10, breadth is 20. So, what will happen? So, your rectangle function, right. So, you are passing, in fact, so you call it as a R is invoking get data. So, R is under rectangle, right. So, it's publicly inheriting shape. So, it is going to shape, right. So, get data, assume that I am passing 10 and 20, n is 10 and m is 20. So, that means A will get the value 10 and B will get the value 20, right. A will get the value 10 and B will get the value 20, right. So, now what is happening? So, your get data, that is what you are doing, right. A is getting the value 10 and B is getting the value 20. So, now what is happening? You have R dot rect underscore area, right. R is invoking rect underscore area. So, what is happening with rect underscore area, right. So, here you go rect underscore area, yes. So, here you have result is equal to A star B, right. So, I passed, as I said, I passed 10 and 20. So, 10 and 20 will be multiplied. So, you will get 200 if you are passing 10 and 20, alright. So, it will be stored in result and it is returning result, right. So, when it is returning result, it will be stored in M, right, it will be stored in M, right. R is invoking rect underscore area, already you have 10 and 20 value. So, these 10 and 20 will be multiplied and that is being stored in result, right. So, next line you are seeing return result. So, 10 and 20 will be multiplied and then 200. So, result is 200. So, that value will be returned. Okay. So, that is what exactly happening over here. So, whatever the value it is returning will be stored in M and in the next line you are displaying the area of the rectangle and whatever be the M value will be displayed, right. Similarly, so let us give base and height, another data you are providing, right, base and height, right. So, Endel it will be, right, next line. So, you are providing base and height, the user is providing base and height. So, when you are providing base and height, here you go, the T is invoking get underscore data, right. So, T is invoking get underscore data, you are passing base and height, right. So, T is invoking get data by passing base and height. So, you can see that, alright. So, you can see that the get data A and B, assume that I am passing let us say 50 and 100, right. Now, n is 50, here you are passing 50 and this is 100, n is 50, m is 100. So, that means A takes the value 50 and B takes the value 100, right. So, that means you are taking the base and the height, right, from the user and you are passing, let us assume 50 and 100. So, get data A and B will be now 50 and 100. So, now again line number 45 T. So, T under triangle, right. So, triangle is accessing shape, right, is inheriting shape. So, T under triangle will be invoking the function triangle underscore area, right. So, when it is invoking triangle underscore area, so here you go, right. So, this is the member function, 0.5 will be multiplied by A and B. So, that is a base and height. So, 0.5 will be multiplied by A and B, right. Assume that I am giving 50 and 100. So, half into 50 and 100. So, whatever be the result will be stored in result and your returning result, right. So, this will be assigning to n whatever you are getting as the output in the result by invoking triangle underscore area. That means, the object T is invoking triangle underscore area, the result will be put into n, right. So, area of the triangle you are getting n, right. So, earlier area of the rectangle we got m, you are passing length and breadth which will be multiplied, right, when R is invoking this function, and similarly when I am passing base and height, when T is invoking triangle underscore area. So, the resultant value will be stored in n, right, and then you are displaying n. So, now we will see what is the output, right. I am passing initially I am passing 30 and 20, right. So, I am passing 30 and 20 here, right. Your length is 30, breadth is 20, and R is invoking rectangle underscore area. R is invoking rectangle underscore area, right. So, what is happening when it is invoking rectangle underscore area, 30 and 20 you are passing. So, A will get 30. So, this is 30 and 20 you are passing, right, 30 and 20, right. Yes. So, A will become 30 and B will become 20. So, in that case what will happen when it is calling, let us say, R rectangle underscore area, right, rect underscore area. So, these two will be multiplied, 30 and 20. So, 600 will be the first output, right. So, for this 600 we are getting the first output, correct. And second case, when I am passing 40 and 50. So, get data is get underscore data base and height, line number 44, right. So, this will become, there is a change 40 and 50, right. So, there is a change here, change in the sense, yes, it is in the different case. So, here you have, so this will be 40 and this will be 50. So, the meaning is A is 40 and B is 50, and when T is calling the function triangle underscore area, it is 0.5 into A into B, 0.5 into 40 into 50, 2000 by 2, which is equal to 1000. So, you have to get the output 1000. So, which we are getting. So, this is how exactly your hierarchical inheritance is working. So, if you look at the diagram, so your hierarchical inheritance is the rectangle is a derived class, whereas base class is shape. Similarly, triangle is the derived class, base class is shape, right. So, hierarchical inheritance in C++ we had seen, and in the next class we will see hierarchical inheritance using Java, right. So, we will see the concept in Java, right. So, with this I am concluding this lecture. Thank you.